Hi everyone, it's Miss Lynn. Today we're going to be doing 1.1 real number notes. We're going to be doing these in week 1. Everybody's going to be on a little bit of a different day. So whenever you're taking these notes, please put the appropriate date. Materials needed for today's lesson. You need a printout of the notes, pencil, your calculator, and 2 different colors. That can be 2 different colored pencils, 2 different colored highlighters. Here's our notes for today. Let's start by putting our name on the notes. My name is Miss Lynn. Whatever period you have my class, I'm just going to write Algebra 1 here, but you are putting your period. And then the date, again, we're doing this within week 1 of school. Practice assignment. You do have a practice assignment. I'm just going to say 1.1, let's just go practice assignment. Okay, below you'll find our standard. What are the subsets of properties of real numbers? Here you can see the standard. Explain why the sum or product of 2 rational numbers is rational. That the sum of a rational number and an irrational number is irrational. And that the product of a non-zero rational number and irrational number is irrational. Okay. Key vocab. Actually, let me scooch this down. Key vocabulary: real numbers can be positive, negative, or 0. There are 5 categories of real numbers: integers, whole numbers, natural numbers, rational numbers, irrational numbers. This is what we're going to be talking about today. A point is chosen on the line to be the origin. Points to the right are positive, points to the left are negative. So here we're just talking about a number line. Zeros are origin, so everything to the right or in the blue is positive. I'm going to make a note here. So these points here, I'm going to say plus, are positive. And these points down here, I'll say minus for negative. A distance is chosen to be 1, then the whole number is marked off, so 1, 2, 3. Also in the negative direction, negative 3, negative 2, negative 1. Any point on the line is a real number. So anything found on a number line is considered a real number. That's important. The numbers could be whole, like 7, rational, like 20 over 9, that's a fraction, or irrational, like the number pi. Okay? All right. Let's go ahead and start with this box to the left. Let's just get some of our key vocabulary down. Make this bigger. Natural numbers, also called counting numbers, are, this word here is positive, are positive whole numbers, starting at 1. So they're called counting numbers, like when you're a little kid and you first learn how to count, it's just 1, 2, 3, 4, 5, and so forth. Those are our natural numbers. Whole numbers are positive numbers starting at 0. No decimals. So the only difference between a natural number and a whole number is that whole numbers include 0. So for example, these would be 0, 1, 2, 3, and so forth. Okay. Integers. Integers are negative and positive whole numbers. Negative and positive whole numbers. So integers go both directions on the number line, like negative 3, negative 2, negative 1, 0, 1, 2, 3. Those are integers. Rational numbers are any number that can be written as a fraction or I'm going to add the word here ratio. Ratio and fraction mean the same thing. This includes terminating. The word terminating means to stop, okay? So terminating, that means stop. And repeating decimals. Okay, so decimals that stop and decimals that go on and on forever. So anytime you see a fraction, that's a rational number. Decimals that stop and repeat are also rational numbers. Last but not least, irrational numbers. Numbers that cannot be written as a ratio fraction, includes non-terminating and non-repeating decimals. Okay, so now let's go ahead and fill in our box. If you guys noticed here, we started at the smallest subset and then we built on it. So 1, then we went to 0, then we went to negative numbers, then fractions and decimals, and the numbers that are irrational or cannot be represented as any of the numbers we talked about above. So we're going to start inside the diagram here, okay? Start in this small box. In this small box, we have natural numbers. Let's actually fill in the words first. These are our natural numbers. Then we move up to whole numbers. So this box surrounding it includes natural numbers. Then we're adding on whole numbers. Then we go up to integers. Okay. Then rational numbers. And then notice this box over here to the right-hand side, there's a line. These numbers are not these numbers. Okay, this is irrational, the only one that's left. Okay. Now we're going to fill in some examples. Examples of natural numbers. These are our counting numbers starting at 1. So 1, 2, 3, 4, 5, maybe 100. Okay, positive whole numbers. Whole numbers are natural numbers except for they include 0. Okay, then it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, things like that. I'm going to take out these commas. Integers now include negative numbers. So negative 1, negative 2. 0 is still an integer. Positive numbers are still integers. Okay. Rational numbers are now our fractions. So for example, negative 2/3. 0 is still a rational number. Negative 3. Decimals that stop, like 4.5. Decimals that repeat, like 0.333. If you guys remember from 8th grade from last year, a line over numbers means it goes on and on forever. Okay. Something that's tricky is we can represent numbers in different ways. So for example, I can write 10/2 is a rational number. I can simplify that down to be 5. The square root of 4 is a rational number. I can make that 2. 5/2 is a rational number. Okay. I can also put the square root of 4 in the integer box because that equals 2. 2 is an integer. Irrational numbers. So popular irrational number is pi, right? That's 3.14159 and so forth. That goes on and on forever without stopping or without repeating. Okay. So anytime you see pi, I would say that is an irrational number. So it can be represented like pi over 2 is irrational, okay? Or 3 times pi is irrational. The other numbers that are irrational that you guys might see are the square root of non-perfect squares, like the square root of 10. So irrational numbers, you have pi and the square root of non-perfect squares. So let's make a note of that. I'm going to say square root symbol of non-perfect squares. Okay. So speaking of perfect squares, we do need to know our perfect squares for this lesson. So top 12 it looks like. Perfect square is 1. What does a perfect square mean? A number times itself. Okay. 1 can be represented as 1 times 1, right? 4 can be represented as 2 times 2. 9 can be represented as 3 times 3, and so forth. 16 is 4 times 4. 25 is 5 times 5. 36 is 6 times 6. 7 times 7, 8 times 8, so forth all the way to 144. 144 is 12 times 12. Okay. If we think about this vice versa, I can say the square root of 144 equals 12. Right? All the square root does is it undoes a square. You guys have that written down? Flip your paper over. Example number 1. Classify each number, describe every group that it's in. Okay. So when it says classify every group that it's in, for example, if the number is -1, it could be an integer, a whole number, and a natural number. If the number is -2/3, oh, nope, I'm sorry, scratch that. If the number is -1, it's an integer and a rational number. I apologize, we're going the opposite direction. 1 is a natural number, a whole number, an integer, and a rational number. Okay? 0 is whole, integer, rational. So 15. 15, I would start with the smallest subset, which is a natural number. I'm going to put n for natural number, and then I'm just going to go up. Okay, so everything above natural numbers, 15 is included in. So it's a natural number, which means it's a whole number, which means it's an integer, which means it is rational. Okay, so start with the smallest subgroup, then everything above that can also be classified. Pi over 2, anything with pi. Our rule, anything with pi, I just want you guys to write irrational. I'm going to put IRR for irrational. Negative square root 16, this is why it's important to know your square roots. The square root of 16, first of all, there's a negative sign, then the square root of 16 is 4. So this number really equals -4. The smallest subset -4 is in is an integer, which means it is also rational. Square root of 6. 6 isn't a perfect square. This is the square root of a non-perfect square, therefore it is irrational. 3/4 is a fraction. All fractions are rational. 1.2, this decimal repeats, therefore it is rational. All right, example 2a, complete the addition table. Write all numbers in decimal form. So this is like a multiplication table that you guys may have done in elementary school. So it's like 5 plus 5, which is 10. Okay. 5 plus 1/2 is 5.5. 5 plus 0 is 5. 5 plus square root 2. This is something that you need to type into your calculator. 5 plus square root 2 is 6.414. Then I'm going to go ... That keeps going. 5 plus negative square root 2 is 3.58. That number keeps going. 5 plus pi is 8.14. That keeps going. Okay. Let me erase this. I don't like how I wrote that. Okay. What I'm going to do is I'm going to pause the video now. I would like you guys to pause as well, and I'm going to complete the rest of this addition table, and then we will meet back up. Okay, here is my table filled in. Again, all I did was add the numbers. I know this looks like a lot. This is where your two different colors comes in. We're going to classify these numbers as rational and irrational. So we're going to make a table to the side. Okay. I'm going to do the colors yellow and pink. I'm going to just make myself a key. I'm going to say yellow is going to be all of my rational numbers. Highlighting my rational numbers in yellow. And I'm going to make pink my irrational numbers. Spelled that wrong. There's two R's in irrational. Okay. Okay, so here's how we're going to organize it. We're going to split the table into 4 sections. Here is a section. Nope, that is sloppy. Okay, what I want you guys to do, let's actually start with the outside numbers. What I want you to recognize, I'm going to highlight or circle these numbers in yellow because 5, 1/2, and 0 are rational. Up top, circle these numbers in yellow. 5, 1/2, and 0 are rational. Vice versa, square root 2, negative square root 2, pi are irrational. I'm highlighting those in pink. Same over here. So the question is, what happens when we add a rational number to a rational number? You should notice all of these numbers in this box are also rational. With your rational color,
tomorrow and Friday, please do not park on the bus loop. That is where
I want you to highlight this box in yellow.
Again, on the bus
These
loop,
numbers
this
are
Thursday
all
and Friday,
rational.
please don't park there. Thank
Okay.
you.
In other words, every rational number plus rational number turns out to be rational. Let's see what happens when we add rational to irrational. Take a look at all of these numbers. We got some ugly decimals that went on and on forever without repeating. That means that they are irrational. So I want you to highlight, color this box. So you can box it around like this. You can color it in. This whole section here is irrational. Okay? This means rational plus irrational yields us irrational numbers. Same thing here. Rational plus rational. All of these numbers are a decimal that goes on and on forever. All of these numbers are irrational. Last but not least, irrational plus irrational. There are 2 numbers here that are rational. For those of you who can see it, those numbers are 0. 0 is a rational number. 0 is a rational number. The rest of these numbers are irrational, so I'm going to color code in my pink color. Okay. So to sum up the table, every rational plus rational yields us rational. Every rational plus irrational yields irrational. However, an irrational plus an irrational number can either, or sometimes, I should say, sometimes be rational, or in the pink, sometimes be irrational. All right, let's go down to the next box. Now we are multiplying. Complete the multiplication table. Same idea, except for you are multiplying, and you guys can use your calculator here. 5 times 5 is 25, right? 5 times 1/2 is 2.5, just rounding. 5 times 0 is 0. I'm going to do the same thing. I'm going to pause the video. I want you guys to pause to finish filling out this box, and then we will meet back together. Okay, here's everything filled in. Very similar to last time. Take your two colors, whatever color you used for rational, use that same color. Let's make ourselves a key again. Yellow, I used for rational. Pink, I used for irrational. Okay, let's start with the sides. Again, 5, 1/2, and 0. These are irrational numbers. 5, 1/2, and 0 are irrational numbers. Square root 2, negative square root 2 pi. I'm sorry, 5, 1/2, and 0 are rational numbers. Square root 2, negative square root 2, and pi are irrational numbers. So we are color coding our answers. This whole box up here are rational numbers. Okay? So a rational number times a rational number is rational. Then with your pen or your color, we're just going to color all the rational numbers. 0 is rational, 0 is rational right here. So you have a T. And then this box here, 2, -2, 2, -2, these numbers are also rational. Everything else is irrational, so I'm going to do my pink. And down here. Just going through and seeing what this says. Rational times irrational. We have zeros here, so this is sometimes rational. Same thing here, sometimes rational. Irrational times irrational does yield us some rational numbers, so sometimes rational, sometimes irrational. All right, now let's put everything together. If this confused you, if these boxes confused you guys, you can completely ignore them, because the important takeaway of this are going to be these boxes down here, these things you're going to have to memorize. Okay, if not memorize, then think of when we did these boxes. So example 2C, based on the above information, conjecture which of the statements is always true, sometimes true, never true. Sum of real numbers. So we're using this box here. Again, rational plus rational is always rational. Irrational plus rational is always irrational. Irrational plus irrational, sometimes rational, sometimes irrational. That's the idea. So the sum of a rational and a rational is rational. This is always true. I'm going to write the word always. The sum of rational and irrational is irrational. Again, we saw this is also always true. The sum of irrational and irrational is irrational. We saw this is sometimes true, okay, because we got the number 0, which was rational. It's sometimes true. Now product or multiplication box going through. The product of a rational and rational is rational. Rational times rational, this whole box was yellow. This is always true. Product of a rational number and irrational number is irrational. Rational, irrational, I have both pink and yellow. That means this is only sometimes true. Last but not least, the product of irrational and irrational is irrational. Irrational times irrational, this section down here, we got yellow and pink. So this is sometimes. Okay? And that is our 1.1 real numbers notes.